Section 8.3 continued. Here I want to graph the logarithm function that is given. Y equals log base 3 of x. I'm going to write that in exponential form, which gives me x equals 3 to the y power. Now what I want to do is select ordered pairs to graph. I've already graphed the function, as you can see, but let's see how I determined that. One of the easiest ways to do it is actually find the value of y first. Here, if I have y equal to 0, 3 to the 0 power gives me x to equal to 1. You can do that in reverse order if you like, but it's easier to find the y. But if you did do it in reverse order and you found the x first, if I wanted x to be 1, then I would have to determine what value of y gives me a 1, which would be 3 to the 0 power. Therefore, I continue by selecting my value for y, because that's the easiest way to do it. If I want y to be 1, 3 to the first power, x then would be 3. If I want y to be 2, 3 to the second power, my x then would be 9. If I continue going with integers that are positive, then you can see that my numbers are going to grow very rapidly. Therefore, what I'm going to do is select values of y that go negative. Y is a negative 1 gives me 1/3. Y to the negative 2, or 3 to the negative 2, is going to give me 1/9. And 3 to the negative 3 is going to give me 1/27. And you can see I've graphed my function. And now what I want to do is determine the domain and range. Here, my domain, x, such that x is greater than 0. And my range, y, such that y can be all real numbers. And from my domain, I can determine that I have an asymptote at x equal to 0. At the beginning of the section, we determined that the log is the inverse of the exponential function. And you can see that my domain and ranges are flipped, which means that gives us the inverse, and my asymptote, which used to be y equals 0 if I had an exponential function in this type of format, now my asymptote is x equal to 0. Our next graph is y equals log base 4 of x plus 5. Recall, as we did in the previous section, I want to perform this by translations. In other words, I wanted to do the parent function. So I want to graph y equals log base 4 of x. And I put that in exponential form, which gives me x equal 4 to the y. And I select y values, and that will determine my x. Y is 0, so 4 to the 0 gives me x of 1. Y of 1, 4 to the first power gives me 4. 4 squared is 16. 4 to the negative 1 is 1/4. 4 to the negative 2 is 1/16. And you can see I've graphed that function. This is my parent function to the graph they want me to find. I have the domain, which we know is x is greater than 0. My range is all real numbers. And my asymptote is at x equals 0. Now what we want to do is to translate that by x plus h, or x minus h. But since this is a minus 5 here, I'm going to move all my ordered pairs to the left 5 units. Let's begin here. So I'm going to move this 5 units left. 1, 2, 3, 4, 5. Again, move this 5 units left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this was a guess at a x value of 16 on the graph. But I can move it back 5 units, which would put it back to 11, which is approximately there. Now I can connect my points. And then I can determine the domain and range of that new function. I have a domain, x, such that x is greater than 1, 2, 3, 4, 5, a negative 5. And my range, y equals, or can be, all real numbers. my asymptote is going to be at x equals negative 5. Of course, that is determined by my translation given in the problem. On this example, they want me to graph y equals log base 4 of x minus 3 minus 5. To do that, I graphed its parent function, which is y equals log base 4 of x. I converted that to exponential form, and then I selected y values and then determined the x from that. For example, I selected y to be 0, so 4 to the 0 is 1, and I continued to do that. I then graphed those ordered pairs, as you can see on the graph. I can determine the domain and range. The domain, x is greater than 0. The range, y can be all real numbers, and I have an asymptote at x equals to 0. Now what I can do is perform the translation from that parent function of the graph they want. This is going to do a horizontal translation to the right 3 units and a vertical translation down 5 units. So let's begin. To the right 3 units, 1, 2, 3, down 5. 1, 2, 3, 4, 5. Again, to the right 3 units, 1, 2, 3, down 5. 1, 2, 3, 4, 5. Next, to the right 3 units, 1, 2, 3, down 5. 1, 2, 3, 4, 5. And my last one, to the right 3 units, 1, 2, 3, and down 1, 2, 3, 4, 5. That would be off my screen, so I'll just ignore that last ordered pair, but I can see what my function is going to look like, so I can connect my points. And then determine this domain and range and the asymptote of the new function. So my domain, x such that x is greater than 3. My range, y can be all real numbers. And my asymptote is going to be at x equal to 3. Of course, that's determined by my translation from my parent function. In this example, I want to write each equation in exponential form. Here I have log base 3 of 6,561 equals 8. Exponential form is 3 to the 8 equals 6,561. Log base 7 of 1 over 49 equals a negative 2. 7 to the negative 2 equals 1 over 49. Log 1 equals 0. Since there is no base displayed, I know this is a common log, so it has a base of 10. 10 to the 0 equals 1. On this example, they want me to find the inverse of each function. Here's our procedure. We have y equals log base 5 equals x. We want to convert to exponential form. That's going to give me 5y equals x. Now I want to change x's to y's and vice versa. So I'm going to have 5. That is a y, so I'm going to change it to an x. This is an x, I'm going to change it to the y. Solve for y, which I already have. Y equals 5 to the x. Again, follow the same format. I have y equals log base 3 of x minus 5. Convert to exponential form. 3 to the y equals x minus 5. Change x's to y's and vice versa. I have a y here. That's going to become an x equals, that's an x. That'll become a y. And then solve for y. So I'm going to have y minus 5. Add 5 to both sides. Y equals 3 to the x plus 5.